This is GMATS 41, your channel of excellence. I'm using this opportunity to welcome you to our live class as I carry you through, brief revision on organic chemistry practical work. And some students, some friends will be sitting for this exam starting this week. Yeah. And so it's quite necessary for us to have a brief review on this organic chemistry practical. Already on this channel, you've got wonderful works, wonderful practical works, on this particular course, Chem 108. That's the course code. And the course title is Organic Chemistry Practical. Please, dear friends, as you join this class, give it a like. Then quickly do me a favor. Help someone out there. Share the link to this particular live class to your WhatsApp groups, your departmental WhatsApp groups, to your friends. Invite them to join this class right away. If you have any question as you're moving on, you can always type your question and I will respond as much as possible. Now, without wasting time, we are going to move on to what I've got for us. I decided to go on screencast format or mode for this class. I wasn't around before. I made a trip for a wonderful convention program in order to be instructed by our God and helper Jehovah. Just came back from the convention with the title Pure Worship, and I've learned so much. I just came back this evening and I just had to hold this class, okay? So make sure you follow through. I believe that with the works you're going to see, I've got slides, okay, slides that I'm going to display. So you can be able to write things fast. You might decide to screenshot, however you want to do that so as to get a work. Now, let me quickly say this, that works on solubility test is already available on this channel on video format. If you go through the GMAT 41's playlist, Chem 108 playlist on this channel, you would see one of video lesson, on solubility test. Okay, then we've got wonderful work on tests of saturation and unsaturation. Okay, test of saturation and unsaturation to test for alkenes, alkynes, and alkanes. So you make use of the works that are already here. What I want to do is to hit on the other aspect that maybe you've not seen works on it on this channel, although these stuffs, they already appear on the GMAT 41's Chem 102 organic chemistry lecture. Yes, the theory part. But I want to put it in practical format, and that's why we are holding this class. So I'm saying this so that you'll be aware of what is already available on this channel, okay, so you can make use of them. Because I'll be kicking off from another homolog quickly, which is alkanols. Like I said, alkane, alkene, alkyne, solubility tests. Okay, solubility test. The use of sodium nitroprusside to test for the presence of nitrogen, the presence of halide, the presence of sulfur. They're already available on this channel. Okay, so make use of them. Yes, Augustine, I really hope this goes well. Network is a bit bad from this end this evening, but I hope it goes well. So far, it is going well. So let us get to business. Imagine that you are exposed to a practical question starting from tomorrow for those that are having this exam. And then you are exposed to an instruction. Remember, you'll be given an instruction as usual. You guys have already done this in your laboratory work. So what we are doing now is not as if it's something too new. And I've actually done the best I can also guide you on those practical works as well too. So I want to believe you can follow through. We're going to be fast as much as we can, okay? I really need to rest tonight. I still have classes tomorrow. So imagine in the instruction you are given a sample, and to the sample you are to test using what we call Lucas reagent. Lucas reagent. Now it is either the term Lucas reagent is used, or the examiner in the instruction will provide the instruction or present the instruction in such a way that you are told to add zinc chloride, after which you add conc HCl. What are you expected to do in that case? What should you know? So like I said, we'll be moving on straight to this, okay? So I'm going to display that. Like I said, I have a slideshow of about 9 of them, which covers everything. Yes, everything possibly you are going to be tested on. So definitely your exam questions will be based on one or more of the things you're going to see tonight, plus the works on alkanes, alkynes, solubility tests. Are you following, right? That I had told you. So imagine you have an instruction where you are asked to add, all right, you are asked to add iodine solution to a given sample, after which you follow it by adding aqueous sodium hydroxide, that is sodium hydroxide solution. An instruction is given to you. We are assuming, remember, we don't know what the exam question is. Okay, so, but the point is, whatever your examiner is setting as exam question, whatever you're going to see starting from tomorrow, must fall within the things that you're going to see me analyze. So you're given an instruction, and then maybe you're told to sample this. Okay, add iodine solution followed by sodium hydroxide solution. This reagent as presented, iodine solution and sodium hydroxide solution, is expected to test for a particular homologue. That homologue is alkanol or alcohol. Old name, alkanol or alcohol. Now, what are you going to observe? Look at the observation as showing on the screen. If you add iodine solution to a sample, if that sample is an organic compound, an organic sample, after adding iodine solution, you now add sodium hydroxide solution. And then it happens that you observe in the test tube that there is a yellow precipitate. So let us say yellow precipitate forms. That's what you see. For seeing that yellow precipitate forming, it simply tells you that what is present is alkanol. So you conclude under the inference, alkanol present. Alkanol present. So what are you expected to know, at least theoretically, before you move on into the examination hall? You have to know the reagent used in this case to test for alkanol. I had said something like this in previous works. Are you following? On chemistry practical. You can't enter chemistry practical exam without theoretical background, without theoretical knowledge. You're only going in there to get yourself into trouble. I know that some of you might not like to hear the word to fail, but I think we want to be honest with ourselves. If you don't have the theoretical background, as you're going to learn tonight, and or as you have learned so far from this channel, then you're only heading for trouble, because whatever you are seeing there, you won't know the conclusion to make. You won't know the inference to make. So one of the most important things you want to bear in mind is the reagent used to carry out the test. So once again, to a sample of an organic compound, remember much of what you're going to do in your practical work in organic chemistry, there are organic compounds that you're testing for. So to a given sample of organic compound, you add iodine solution, and then you follow it up by adding sodium hydroxide. Let us assume now that what you see in the test tube is a yellow precipitate. So once you see that yellow precipitate, it means that alkanol is present. In my analysis, I went in the direction of positivity. I applied positive test. What do I mean? Saying that, okay, you see this homologue, because of this reagent, this is the homologue that's going to be there. So I am a kind of identifying the homologue that is present, the organic compound that is present. It is possible that you are tested in the negative direction. Take note. What do I mean by the negative direction? Whereby you would record that that homologue is absent. Yes, you can do that. Okay. My worry, yeah, I must be honest, but it's so sad that we find ourselves in such a place where so many people are doing things just the way they want, I have got this report that in your laboratory works, yeah, some of you students, okay, like in Unizik or so, sometimes during the time you were carrying out all this experimental work weekly, that some of the results you are getting does not tally with what is expected. Even the lab technologist or yeah, guiding you people, some of them would even mention to those that prepare the reagent that this is not given the result that is expected, and then they will tell them to calm down. Well, I just hope they have fixed that before your exam. Okay, I just hope they fixed that. But all said and done, you want to have this theoretical knowledge so that should anything happen, you will know what to record. Should anything happen, you will know what to record. If I am in the examination hall and you give me iodine solution, give me sodium hydroxide, you say I should add it to an organic sample. With those reagents, the two reagents mentioned, I am already anticipating that what should be there is alkanol. And how would I know that alkanol is there? Look at the observation. There should be a yellow precipitate form. When in the test tube, you add iodine solution and then add sodium hydroxide solution to that organic sample, you are expected to see a yellow precipitate. So yellow precipitate will form, and once that forms as observed in the test tube, in your inference, you now conclude that alkanol is what? Add iodine solution and then add sodium hydroxide solution. It happens now that in the test tube, there is nothing like yellow precipitate. Nothing like yellow precipitate. In that case, you cannot conclude that alkanol is present. You can't. Rather, what you would say is that alkanol is absent. That is what you're going to write there. I didn't show that in the work, the slide work I'm displaying, because I can't just do that. If I go in that way, maybe you might just be confused. Okay, so like I told you, I decided to approach this in the positive direction, assuming that, okay, based on the reagent given to me, this is the homolog. This is the organic compound that is expected to be there. So suppose the observation does not follow what you are seeing on the screen, you can now conclude that that organic compound, that homolog, supposedly, which I tested to be positive here, you now conclude that homolog is not there. That is, if the observation does not follow what you are seeing on the screen. I've taken my time to explain this so that I can be able to speed up as we are moving on. So we are still on that number one, sample A. Maybe in the instruction, you're asked to add iodine solution followed by sodium hydroxide solution to an organic sample. If you do that and you see a yellow precipitate, okay, you record yellow precipitate forms or yellow precipitate formed. You can record in simple present tense or in simple past tense. I've already said stuff like this, you know, from your Chem 107. So you conclude alkanol is present. But what if on adding this reagent to the organic sample, there is no yellow precipitate formed? You conclude, under the inference, alkanol is absent. All right, we are done with that. Let us move on. Assuming that alkanol is present, an examiner might want you to carry out further tests in order to classify the alkanol, whether the alkanol is primary, secondary, or tertiary alkanol. An examiner can ask you further questions. In such case, you might be asked to divide that organic sample into maybe 3. As the case might be. The first test there confirmed that, okay, that sample is an alkanol. What if the examiner is interested in your telling him or her whether the alkanol is tertiary alkanol, secondary alkanol, or primary alkanol? Now you have 2 there. Sample A, that's the second portion of sample A. Are you following, right? Add zinc chloride. Add concentrated hydrochloric acid. So you see the reagent we added there. Zinc chloride and ConKCl. Suppose you add zinc chloride and ConKCl to an organic sample, and then you observe in your test tube that immediately that solution becomes turbid. So solution immediately becomes turbid. Oily layer forms. Or solution immediately became turbid. Oily layer formed. Okay, I said you can report either in simple present tense or you report in past tense. There are some I reported in simple present, then towards the end, there were others I reported in simple past. So you get the format. Anyone you want to use, you use it. Don't mix them up. If you're reporting in simple present tense, use simple present tense all through. If you're reporting in simple past tense, use simple past tense all through. Sorry, please, what topic? Breezy GMR. This is organic chemistry practical analysis. All right, let us move on, please. If the solution immediately becomes turbid, and you see something like oily layer as well too, then you conclude that tertiary alkanol is present. Tertiary alkanol is present. You can still write confirmed, because this is the way you confirm tertiary alkanol. So the idea is this: the reagent, you see the zinc chloride and HCl. You can use it to confirm the presence of tertiary alkanol. When you add this reagent to an organic sample that contains alkanol, immediately reaction starts and the solution will become turbid, not clear. Not clear. You might be seeing some things like, I see there is oil in it. You know how your oil behave in water. Are you following, right? Yeah. But that idea of turbidity should be your focus. That solution will no longer be clear. So you confirm tertiary alkanol. We move on to number 3, another sample of, another portion of that organic sample A. You add zinc chloride followed by HCl. Now, in this case, we are now assuming that, okay, maybe it is not tertiary alkanol that is there. If it is not tertiary alkanol, of course, the solution will not immediately become turbid. It won't. So look at that number 3. Solution, sample A rather, plus zinc chloride plus HCl. Solution becomes turbid in about 4 minutes, forming oily layer, which means you might have to wait when you add that zinc chloride and then you add the HCl. You might want to observe the test tube a little. Are you following, right? Yeah. Within some minutes, there are about 3 to 5 minutes. Yeah. But I decided to pick like about 4 minutes. The solution will now start getting turbid, losing its clarity. Once you observe that, it means that the alkanol you have there is secondary alkanol. So under the inference, secondary alkanol present or confirmed. Remember, if you don't see these observations, they are not there. You're not observing that. But then they use this reagent. Then what you have to tell them is absent. But please, this is what I want to advise you on. Read through the instruction first. The last thing they ask you to do, the last instruction in any sample analysis is very, very important. Because sometimes, I am sorry to say that, apology to you people, but I'm not sorry and I'm not apologizing to those that are in charge of these experimental works, because they are the ones that are supposed to prevent this thing. However, they do not prevent it sometimes. Sometimes their reagents might be faulty. Their apparatus might be faulty. Such that if you are carrying out this experiment, you won't be seeing all these reactions. You won't be observing these things you are learning here. If you are not observing them, and then the last instruction does not take your mind or direct you to another dimension of another different homologue, there is no change to maybe you're trying to confirm another homologue. Nothing like that. Like in this case, now let me just assume I give you a question now, right? I give you a question, give you an organic sample, tell you to divide that organic sample into maybe 4 portions, just like what you have here, because this is just like 4 portions. To the first portion, add iodine solution, followed by sodium hydroxide solution. To the second portion, add zinc chloride, followed by HCl. Are you following, right? And then maybe I just stop there. These reagents mentioned in the question are the reagents you use in organic chemistry tests to verify the presence of alkanol, right? So if I stop there in telling you, okay, first portion add iodine, second portion add zinc chloride and HCl, It means that it is alkanol that I actually want you to confirm, not something else, not another homolog, because these are the reagents we use for alkanol. So since in the last instruction, the examiner did not drive me to another reagent that could have been used to confirm a different homolog, which is not alkanol. Since the examiner didn't give me any other different reagent, I would know definitely that what likely is there is alkanol. So that even though the reaction is giving me what I'm expecting or not, the observation should follow the pattern of what you are learning theoretically. Because like I said, their faulty apparatus could cause you trouble. But my honest wish and prayers for you, friend, is that you have the right apparatus and reagents, okay, provided. Yeah, that's my honest prayers. So that at least you'll be observing those things and knowing what you are writing. But all the same, be guided by what I am explaining to you right now. Okay, now let's move on to the other sample, the other portion of sample A. Let us assume that on adding zinc chloride followed by concave Cl, you waited for like 4 or 5 minutes, nothing happened, no turbidity. That shows that it is primary alkanol that is there. That shows that it is primary alkanol that is there. So you take note of this analysis. We are done with that of alkanol. We are done with that of alkanol. So I hope you have taken this down or screenshot the work you have there. I hope you've taken it down or screenshot. Like I said, if you have any question or anything, you can ask your question. Okay, you can ask if there is something you do not understand. Okay, guys, let us move on to the next analysis. Let us move on to the next analysis. Let us move on to the next analysis. So here we go to the next homolog. We are done with alkanols. So this is the reagent that is being used. I've mentioned it. So be guided. In case you read and in an instruction, you're seeing something like iodine followed by sodium hydroxide, you're seeing zinc chloride followed by concave Cl, start thinking alkanol. Start thinking alkanol. Let's move on to the next homolog that I have here in the next slide. I decide to say, okay, let us label that organic sample as sample B. Let us label that organic sample as sample B. So imagine that in your question paper, you see this instruction to this you're given an organic sample, an organic compound, all right? Then you're asked to add neutral potassium tetraoxomanganate 7 to it. Neutral potassium tetraoxomanganate 7. When you add neutral potassium tetraoxomanganate 7, take note, not acidified, not alkaline. Remember, sometimes you usually have acidified tetraoxomanganate 7 or alkaline tetraoxomanganate 7. But this one, not is just that tetraoxomanganate 7, so it is neutral. Now, if in the test tube you observe purple color, you observe rather that purple color of potassium tetraoxomanganate expects the following. So let's move on. Remember to share this link to your friends, please, to your departmental WhatsApp group. Help somebody. For those taking this course, this is your second semester. You really don't need to take any chances because it's your last semester in the level you are. I'm going to do everything to score a very good point. Yeah, excellent grade in it. I think this course is a pure A course. That's the truth. It's very simple to blast your A. Worst come to worst, the least you can get after all this coaching should be B. That is worst come to worst. It's a pure A course. So help someone out there, share this link. Okay, this class is open to everyone and it's free of charge, you know. But support GMAT 41, I will appreciate that. Join on the platinum level and the diamond level. Remember, there are many more to learn from this channel. Let's move on. So if you observe that the purple color of potassium permanganate becomes colorless, the inference would be that aldehyde, that is alkanal, alkene, and alkyne suspected. Are you following right? These are the things you're going to suspect. The reason is because these three guys will decolorize. They will make the purple color of potassium permanganate to become colorless. Under tests for saturation and unsaturation, the video lesson on this channel, if you scroll to GMAT 41 Chem 107/Chem 108 playlist, organic chemistry playlist, you would see a lecture video on tests for saturation and unsaturation. Potassium permanganate will be decolorized. That purple color will be lost if you pass an alkene through it, or you pass it through an alkene, or you add it to an alkyne. The same thing, aldehyde, that is alkanal, will do the same thing. So if you observe this, then you suspect these guys, right? Now, how can we try to differentiate or actually know the organic sample there out of these three that we suspected? Look at this second test. When in the second instruction, you are asked to maybe another portion, second portion of that organic sample, add 2,4-dinitrophenylhydrazine. 2,4-dinitrophenylhydrazine. Of course, the solution will be provided for you, to be there for you. So if you are to add this solution to, let's say, another portion of that sample B, and then in the test tube, you observe a yellow or orange precipitate. This is where this thing becomes messy. This is where it becomes messy. If, let us assume that someone only knows that it is yellow precipitate that will be formed, and in the exam hall, you are no longer seeing yellow precipitate, let us assume what you're seeing is orange-like, you might be thrown off balance. It's possible that some of you had this problem, and maybe whomever that is coaching you in your lab might not have been aware that this could have another color. So you take note of this. If you add 2,4-dinitrophenylhydrazine to an organic compound, an organic sample, and you see either yellow or orange precipitate form, right? What is present there is a carbonyl compound. Either alkanal, that is aldehyde, or alkanone, that is ketone, suspected. You can see it in the inference column there. Carbonyl compounds present, aldehyde or ketone suspected. So do you see we still have problem? We've not been able to conclude what really this sample B is, because we are still suspecting two of the carbonyl compounds, aldehyde and ketones. This might take us to a third sample, a third portion of that sample of the organic compound. So look at number 3, sample B. That's third portion of sample B, possibly. You are to add Ferlin solution to it and then heat. Sometimes you might not see that instruction of heating, you might not. But on a normal, for accuracy, you are meant to heat that mixture. If you have an organic sample, you add your Ferlin solution and then heat. But let me say this, whether you heat or not, just observe, right? Just have an open mind and observe very well. If on adding Ferlin solution to that sample, you now observe a brick red precipitate form. You observe brick red precipitate form. That shows that the carbonyl compound present there is aldehyde. You can see the inference there in that number 3. Aldehyde present. You now notice, you observe that we have kicked off ketones. That is alkanones. We've kicked it off because Ferlin solution is used to confirm between the two carbonyl compounds, alkanal and alkanone, also known as aldehyde and ketones, respectively. These two guys, you differentiate between them using Ferlin solution. Does that make sense, right? Good. Instead of Ferlin solution, look at another reagent you might be exposed to. I am strongly suspecting, you see that one in number 2, number 3, and number 4. These are the 3 guys I'm actually even suspecting if you are to test for alkanal and alkanone. The KMNO4, you may or you may not. It's possible. But if you see, no problem. That's 2, 3, 4. Those reagents there. Yeah. Okay, number 4. Number 4. That number 4, some of the batches might be exposed to it if your examiner is testing you on these carbonyl compounds. Some set, they might expose them to use this silver triazonitrate 5. That's reagent is actually called Tollens reagent. Tollens reagent, yeah. Look at that number 4 once again. Sample B plus silver triazonitrate 5 plus aqueous ammonia. That mixture, silver triazonitrate 5 and aqueous ammonia, is called Tollens reagent. So like I said, instead of going through the direction of number 3, where you are adding Ferlin solution, an examiner might decide to go through that direction of number 4, where you use Tollens reagent instead of Ferlin solution. Yeah. They can't combine both of them like this. No. Because once you've used Ferlin solution, it's sufficient to differentiate between alkanal and alkanone. Or you use Tollens reagents, that is adding silver nitrate and aqueous ammonia. It is sufficient to differentiate between alkanal and alkanone. So it is either after that number 2, that's the organic sample, you add 2,4-dinitrophenylhydrazine and you observe either yellow or orange precipitate form where you suspect either aldehyde or ketone, alkanal or alkanone. The next thing, in order to confirm between the two which one is actually there, the next thing the examiner would have to expose you to is either taking you through the direction of using Ferlin solution or taking you through the direction of using Tollens reagent. In the case of Ferlin solution number 3, you can see that the observation, the brick red precipitate will form in that test tube. You conclude aldehyde, or you can say alkanal present. Okay, you can also say confirm, no problem. Then, if the direction you are being driven through is use of Tollens reagent, fine. What will be the observation? A silver mirror deposit will form inside the walls of the test tube. As you add the Tollens reagent, that is the sample, the organic sample, you add silver triazonitrate 5 solution to it, then follow it up by adding aqueous ammonia. In the test tube, you would see the inner wall of the test tube. Inside the inner wall of the test tube. All right. Sorry, but is it possible to also do this live video on Star 202? Yes, I will do a live class on Star 202, but please, we are focusing on Chem 108 for now, okay? So guys, I think I am done analyzing this test for alkanal specifically, because that's what we'll confirm here. Yeah, we actually approach carbonyl compounds, and we had problems. The problem we had is we suspected the 2 carbonyl compounds because of the use of 2,4-dinitrophenylhydrazine. Then we now had to differentiate what is there. And we had to go in the direction of what? Alkanal. Now take note. I have carried out the positive tests to confirm aldehyde. I have carried out the positive test to confirm what? Aldehyde. What if maybe on adding Ferlin solution, there is no brick red precipitate? If there's no brick red precipitate, you conclude aldehyde absent, ketone suspected. Yes, you cannot say that ketone confirmed. You can't say that there because this is not a confirmatory test for ketone. You can just say ketone suspected, yeah. Or you add Tollens reagent and you did not see anything like a silver mirror deposit inside the walls of the test tube. You cannot conclude that aldehyde is confirmed. No. You would say that aldehyde is absent. So you see, your examiner gave you those reagents, but they are aware that aldehyde is not there. Now, since you suspected aldehyde and ketones, that is alkanal and alkanone, from using 2,4-dinitrophenylhydrazine, it is expected that, okay, if this reagent used to confirm the presence of alkanal, if they do not show the positive reaction or observation that alkanal is expected to show, You now conclude that aldehyde is absent, alkyl present. Does that make sense, right? Yeah. So that's how you handle that. And I guess we are done with this particular guy. Like I said, if you have a question, you can ask. What if the number 2 carbonyl is absent? What if the number 2 carbonyl is absent? All right. Now let us look at that number 2. Assuming you add that 2,4-dinitro, okay, that is, you add 2,4-dinitrophenylhydrazine. And then in the test tube, you're not seeing anything like yellow color precipitate. You're not seeing anything like orange color precipitate. Then it means that carbonyl compound is absent. Carbonyl compound will be absent, which now leaves us with what? Alkenes and alkynes. So you now write there alkenes and alkynes suspected. Because what you have done is actually to eliminate the possibility of seeing carbonyl compounds. You are now saying that, okay, unsaturated compound will be there, which is alkenes or alkynes. Now, in that case, listen, let me tell you now, okay? Chemezi, I hope you're listening. In that case, your examiner will not tell you to use Ferlin solution again. Your examiner will not tell you to use Tollens reagent. You won't see it in the question paper. You won't. You won't. Since carbonyl compound is absent, we are assuming, based on the question you asked, say you follow through number 2 test using 2,4-dinitrophenylhydrazine, and then there is no yellow color, no orange precipitate formed. Of course, carbonyl compound will be absent, and then you now write alkenes and alkynes suspected. In that case, number 3 will not go as use Ferlin solution or maybe use Tollens reagent. It won't go that way anymore, because the examiner knows that carbonyl compound is absent and that alkene or alkyne is present. So your examiner is now going to expose you to a reagent that is used to test and confirm for the presence of alkenes and or alkynes. So what should you do at this point? You can take the lecture video where I analyzed crystal clear, 100%. In fact, that lecture video was based on last set UNIZIC exam question on organic chemistry practical. Okay? In that case, you'll be exposed to something like using bromine water, something like using ammoniacal silver nitrate or ammoniacal copper 1 chloride. For ammoniacal silver nitrate or ammoniacal copper 1 chloride, you use these 2 reagents to confirm terminal alkynes. Does that make sense, right? So the reagent that your examiner asked you to apply, to use, to add from the instruction is key. It's a strong secret that will guide you, friends, to actually know likely what is the organic compound in that sample. That is why this class, you don't joke with it. You don't play with it. The theory is absolutely necessary. Without the theory, you are going nowhere. That's just the honest truth. You know, I love you guys a lot. I like just being honest, encourage you, friends, and then be practical to you guys. So thank you very much, Chukwuemeze, for the question you asked. Okay, thank you for that question. Like I said, I went in the positive direction in all this. If the observation you are seeing here is not seen, then, of course, the inference will go in the opposite direction. And in that case, your examiner in the next instruction will actually guide you, will tell you the next reagent to use in order to achieve the result they want you to achieve. Because definitely your exam, you must confirm the presence of something particularly. And if you must confirm that 41 is telling you 100%, the network is trying to break. I hope you can see the screen very well. In that case, GMAT 41 confirms to you 100% that your examiner must definitely give you the reagent you will use to confirm the organic sample that is there. All right, we are moving on, please. We don't have enough time. We're moving on. Let's look at the next. All right, so here we go to the next guy. We still have another possible reagent you can be given. Please, this is a continuation from, the test for carbonyl compounds. Okay, test for, you can see number 5 there. We just finished with number 4. And like I said, it is either after this number 2, the next instruction you would see would be the reagent of number 3, or will be the reagent of number 4. Remember, the reagent of number 3 is Ferlin solution, or the reagent the examiner asks you to use will be Tollens reagent, which is that of number 4, or the reagent that the examiner will ask you to use will be that of number 5, which is Chief's reagent. Chief's reagent. Chief's reagent is fission sulfurous acid. Fission sulfurous acid. That is what we call Chief's reagent. It is simply a dye mixed with hydrogen trioxosulfate. Think sulfate 5, yeah. Hydrogen trioxosulfate 5. That is H2SO3. That is our sulfurous acid. That fission there is a dye-like substance. Anyway, your examiner will not bother you about that name, fission sulfurous acid. You will rather be exposed to Chief's reagent. So take note, after this instruction number 2, using 2,4-dinitrophenylhydrazine, if we are now certain that what is there is carbonyl compound, to differentiate between the carbonyl compounds, your examiner can now expose you to either this reagent in number 3, Ferlin solution, or the reagent in number 4, Tollens reagent, or the reagent in number 5, Chief's reagent. Any of these reagents is used to confirm aldehyde, that is, alkanals. In the case of Chief's reagent, what would you observe? Chief's reagent is colorless. All right? Now, when you add it to an organic sample and it changes to pink or magenta. It changes to pink or what? Magenta color. The inference would not be that aldehyde is confirmed or present, whichever you want to write, okay? So take note, I've guided you after that instruction number 1, 2. Now number 3, 4, 5, your examiner is picking just one of them because the idea is to confirm alkanal. And I know for sure that basically it is alkanal. If you're going through this, that you might be asked to confirm. But like I said, if the observation does not go in line with what you're seeing here, then of course you state that alkanal is absent, hence alkanone present. Does that make sense? All right, guys, we are moving on. We are done with this. If you look at this, number 2, number 3, number 4, just a continuation of the other. So we are done with the carbonyl, guys. We are done with alkanol. We shall be moving on. There is no time. Now, imagine that you are exposed to an exam question. You have your question paper. Are you following, right? And then the instruction is given on an organic sample. And then to that organic sample, you are asked to add water. On adding water, you are asked to test with litmus paper, right? Test with litmus. Of course, anytime you hear the concept of litmus or pH indicator, it is to determine whether that solution is acidic or alkaline. So imagine you're given an instruction to sample C, add water and test with litmus. Now let us assume that on testing with litmus, of course, you have your red and blue litmus. You have your red and blue litmus. You hold them. I don't know if you can see this. Let's see. Oh, no, I'm sorry. So I know you guys are good. You're good with this already. So you have your blue litmus. You have your red litmus. You have to act as in dip them into the solution. You dip them into the solution. of course, you can dip both of them at the same time and then observe what the reaction would be. You dip blue and red litmus paper and then check which one will change color. Okay, and then check which one will change color. I know somebody will be saying, why is GMAT stressing himself? You know, we are aware of this already, but it's good. Remember, this class is meant for you to come and learn live. So I don't know if you can see this from there. Just trying to. So this is how you dip both of them. Dip both of them. As you dip both of them, you can see red and blue litmus. You can see red and blue litmus. So as you dip both of them into that solution, observe which one will change color. If it is the blue litmus that changed to red, it means that the solution is acidic, which means that solution of sample C is acidic in that case. But let us assume that it is the red litmus, Let us assume it is the red litmus that changed to blue. Then the solution is alkaline. Then the solution is what? Alkaline. So you want to take note of that. All right. Now, after that instruction, let us assume that the next instruction, the examiner now goes ahead in your question paper to tell you to add sodium bicarbonate to solution of sample C from above. To solution of sample C, add sodium bicarbonate. If you add sodium bicarbonate to it and then you observe that an effervescence occurred. I've explained the concept of effervescence. That sound that your Coke, Pepsi makes, your Sprite, when you open them, when you cork them open, okay? So you hear that sound. Once that is happening, a gas will usually be given off. So look at the observation there. Effervescence occurred. A colorless and odorless gas is given off, which turned blue litmus red and lime water milky. In the inference, what will you write? The gas is acidic. Yes, the gas is acidic. That is why it turned down blue litmus paper to red. Now, in this case, the gas is CO2, carbon dioxide. From what? From carboxylic acid. Which means that this sample C, the organic compound there, is alkanoic acid, carboxylic acid. It is alkanoic acid or carboxylic acid, as you want to call it, that will behave like this, that will show this type of observation when you add sodium bicarbonate to it. Dear students, I want to encourage you on your own. You can decide to ask Google, like you can browse on it. I don't have the time to start writing the molecular formula. You say a chemical formula instead of a name. But in most cases, in most of these reagents, okay, in organic chemistry, the name, the EPAC name is usually mentioned instead of the chemical formula. All right, let's move on. Let us assume now that you are now asked to another portion, to the second portion of solution from one above. Second portion of solution from one above. Add ethanol, followed by tetraoxosulfate 6. Add ethanol, followed by tetraoxosulfate what? 6. And then you notice something, okay, you perceive something. That on adding tetraoxosulfate 6, you know, you add ethanol to the second portion of solution from one above, as you can see on the screen, and then followed by tetraoxosulfate 6. And then you now perceive something very aromatic, right? So sweet. You get that, right? Don't go and drink anything there. Now you perceive this aroma. Then know that what is there is an ester. That is what has been formed is ester. In fact, that reaction is esterification reaction. So in the inference, what you're going to write is ethyl ester or simply ester. Why I decided to write ethyl is because the alkanol added in the reagent there is ethanol. If you add ethanol to an alkanoic acid, the ester you're going to get will be ethyl alkanoate. That alkanoate will now come from the alkanoic acid, okay? But you're not really required to write the full name of that guy that is formed in the reaction process. Okay, so you can just simply write that esters from carboxylic acid group. So you see the way I presented it, ethyl ester from, I wrote the functional group of alkanoic acid group. Are you following, right? And then I now wrote carboxylic acid confirmed. So you take note in case you see something like this. But I believe much more that number 2 instruction is sufficient, yeah, to show that, okay, you are confirming carboxylic acid. Please do not forget what I've told you about the importance of the reagent. Please, dear students, one of the things you must make sure in less than 24 hours for those that are taking the exam tomorrow, being Monday, one of the things you must make sure you do in less than 24 hours is to memorize. In fact, cram. Let me be raw in saying this. Memorize the reagents you use to confirm or to show, identify certain organic compound. For example, if you remember when we treated alkanol, we used iodine solution first, followed by sodium hydroxide to show that alkanol is there. Then to classify the alkanol, so whether it is tertiary, secondary, or primary, we use zinc chloride and followed it up with hydrochloric acid. You see, the fact that I know this reagent, once the instruction I am seeing, add this, add that, I'm seeing those reagents, I will start suspecting, okay, this is likely what the examiner has in this organic compound or organic sample given to me. Then because I know of this reagent and from the theory, I know how this reagent behaves, if it is that organic sample that is there, I'll be anticipating that. I'll be expecting to see that in the test tube. And let me tell you, in 90% of exam questions you are being exposed to, whenever you are asked to use certain reagent, the truth is that reagent will actually test for and confirm what it is used for. Because we don't usually waste reagents. I had said this in Chem 107 last semester. Yeah, I said that our aim in the laboratory is not to test you in the direction where you will go waste reagent. What do I mean by that? Examiner is asking you, add this reagent, add the other one, add this. Knowing that what the reagent confirms is not there, it's not in that sample. And then the examiner is telling you, add this, add. At the end of everything you are writing, this absent, this absent. By the time you finish recording everything, your inference will be absent, absent, absent. At the end, you confirm nothing. Come on, that doesn't happen in a chemistry practical works. It doesn't happen. Are you following? You must confirm something. So this is where you're memorizing, you're cramming this reagent, very important. So that in case you start adding, some of you say, I'm not seeing anything. And of course, reports I had received, yeah, from some of you friends from your laboratory work is so devastating. I'm just putting you friends in God's hand and say, okay, let God be with you. Okay, and then follow this principle. In such worst case scenario where the reagent is not working out, only them know why. Could be as a result of wrong preparation or not giving the reagent enough time to undergo its ionization process as it's supposed to be. All these things can affect, or maybe let's even say dirty apparatus can affect results, can affect observations. So whenever something like this is happening, you have to, sorry to say, in your exam, you have to recall your theoretical knowledge and deliver yourself in that exam. Apply your theoretical knowledge. That is why you see your reagent you're adding here under the test column. You see your observation, what you're expected to see in the test tube if you're carrying out the experiment. Use this also reagents. Don't joke with them. So that once you're seeing something like this in the question, in the instruction, say add this reagent, you remember, oh, this reagent, they said it's used to test for so organic compound. Okay, this is the observation I'm expecting. If you see that, fine, can now be able to write. But in worst case scenario, where the result is not giving you what you're expecting, could be, like I said, due to error, which might not even be your fault. Then let your theoretical knowledge guide you at least to have something written and come out. Besides, we can predict to 70–80%. Yes, we can predict what is there in an organic sample or in any given chemical sample in terms of test analysis. Once you give us the reagent, we can predict. Using the principle that we do not waste reagents. We don't. These reagents are costly. Now, let us move on, please, to the next guy. We're done with this. Now, assuming that some of you in your batch, maybe what your examiner decided to test you on is another homolog, different from the ones we've covered. We've covered alkanol, we've covered carbonyl compounds, we've covered alkanoic acid, that is carboxylic acid group. But assuming maybe your own batch, none of these guys, it's another different homolog. None of network broke a moment, so sorry about that. You're welcome back. You're welcome back. So imagine that you are given an organic sample and then you have this instruction. The organic sample is labeled with any alphabet they want. I decided to use sample D. And then you are asked to add in that your instruction in the question paper, add 20% sodium hydroxide and bore, whether they say 20% or not. Because sometimes they might not even tell you the concentration. Here it's a 20% concentration of sodium hydroxide. Sometimes the instruction, they might not even put it. No stress. Go straight. Now you are told to so organic sample, add 20% sodium hydroxide and bore. Now when you read this reagent, read about adding this reagent to that organic sample, and then when you do this, you observe that a colorless gas, don't mind the wrong determiner, the wrong determiner that I used here, okay? I used uncolorless, sort of a colorless, okay? Don't mind me. A colorless gas with characteristics choking smell evolves. The gas turns damp red litmus to blue rather. The gas turns damp red litmus paper to blue. If this is what you observe, your inference would be gas is alkaline or simply alkaline gas. And the only alkaline gas you have is ammonia. So you have to identify it. So you proceed under the inference and write ammonia gas from, the question now is which homolog produces ammonia gas? When you add sodium hydroxide to it and possibly boil it, which homolog would do that? So you can see that CONH2, which is the functional group of amide. CONH2, which is the functional group of what? Amide. That is why I wrote amide group present. Amide group present. We can go further to really confirm and maybe be sure that yes, it's amide that is present there. Now look at the second test. The second test. Maybe the instruction tells you to the second portion of solution D, or simply to the second portion of sample D. Okay, because whatever that, if it is in liquid form, you can divide it into portion. If it's in solid form, you can actually break, are you following, right, into certain portions, and of course dissolve in whatever reagent that you're using. So to the second portion of D, you are asked to dip a glass rod into conc HCl, that's concentrated hydrochloric acid, and then hold that glass rod close to the mouth of the test tube. Remember, the test tube contains the organic sample. The test tube contains the organic sample, which is sample D. Now, you are asked to dip a glass rod into conc concentrated hydrochloric acid, you dip it, and then place it over the mouth of the test tube, something like this. The nerve, you can see this, something like this, over the mouth. So if there's an instruction like that, it is expected that in the observation, a dense white film of ammonium chloride will be formed. So we have dense white fumes of NH4Cl evolves. Dense white fumes of ammonium chloride evolves. Once you see this, it confirms amide group. So you can just write amide group confirmed. All right. So we are done with this for the amide. I don't know, but my mind is telling me that amide group has very, very low chance of being tested for in your exam. I don't know, but my mind is just telling me that. I'm not saying you should not prepare for it. You have to prepare for it, okay? But I just feel like, All right, let us move on. The next, we have this. Good. You see this guy? The remaining ones that we have, please make sure you give serious attention to them. The remaining ones, make sure you give serious attention to them. Is that clear? These guys, from this one to the remaining ones that we have to treat, give serious attention to them, especially even those of sugar tests, starch tests. Yeah, your examiner. I'm having this strong thought that you'll be tested there. So let us see. You have an organic sample. And you are asked, to this sample, I'm labeling it as sample E. Add NI. Let us assume that, is this network hanging? The network seems to be breaking off and on. You're all welcome to the class. You're welcome. Thank you for joining the class. Please, once you join, like this live class. We are covering as much as 90% of the things, if not 100% of the things you likely are going to be tested in your examination hall in Chem 108. Except for the aspect of saponification because soap making, I don't know, maybe it might be tested, but of course, there is nothing they are testing you the other than maybe describe how you can make a soap and the materials that can be used. Of course, you can work on that because for those in Unizik, for example, I know that you did something like that, I guess. So you can work on that. You can also go through your manual and read through the materials used for saponification and the process. You can be asked to describe it, it's possible. But before you prepare for those parts, make sure you cover all these test, observation, and inference analysis for the necessary homologs. Is that okay? So let us move on. Help and share this link to your departmental WhatsApp group to your friends so they can also benefit. You see, as I'm talking, I know you should be going through what is on the screen as well too. Should be going through it. Okay, so that's good. So imagine to a particular organic sample, you are asked to add ninhydrin solution. On adding it, you now observe in the test tube, all right, that a blue color or purple color forms. One of these color, one of them. So if you see blue, good. If you see purple, still fine. When this happens, what is likely present there is an amine or amino acid. Amine or amino acid. Take note of that. Amine or amino acid present. Now let us go further. Your examiner might want you to classify the amine that is there, if at all it. Seems like network disturbed and logged you friends up. Logged you friends off. I'm sorry. That's the network situation, but we're managing the whole situation, still moving. Let's see what happens. All right, my tracking device is on, so I will know what is happening at that end. So let's see. All right, join up. You are all welcome to the class. You're welcome. Obinna Dindu, you're welcome. Ugu Perpetua, you're welcome. All right, so we're talking about this. Let's move on to 1AII, please. So to second portion of solution sample E. All right, the second portion, you are to add sodium nitrite and then follow it up by adding hydrochloric acid. If you add this and you see gas bubble, if you add this and you see what? Gas bubble. So gas bubble forms. Observation, gas bubble forms. Inference would be primary amines present. Inference would be primary amines present. And if that is the case, you record that. This tells you that primary amines would usually react with sodium nitrite and hydrochloric acid to give you gas bubble. And that gas bubble is actually nitrogen gas. That gas bubble is actually what? Nitrogen gas. So that aside, let us move on to the next one. No time, okay? Let's move on. 1AIII. Solution of sample E. Solution of sample E. You are asked to add sodium nitrite followed by hydrochloric acid. And then you observe in the test tube that yellow oily liquid with fishy odor forms. Yellow oily liquid with what? Fishy odor forms. Then the inference would be secondary amines present. Secondary amines present. You're noticing the difference now. In the case of primary amines, you just see gas bubbles. Okay? If it is secondary amine that is present, that it is not primary amine, you would observe yellow oily liquid with fishy smell, fishy odor. You will perceive it. Okay, now assuming that it is not primary amine that is there and it is not secondary amine that is there, when you add that sodium nitrite followed by hydrochloric acid to that solution, what will happen? You would see that there will be no visible reaction. In that case, tertiary amines will be said to be present. Tertiary amines will be present in that case. But I think to a certain level of confidence, I can tell you that if your examiner wants to test you on this, they will drive you to the direction of either primary or secondary amine. Much more to the direction of secondary amine. Yeah. Much more to the direction of what? Secondary amine. I don't see them really, driving you to the dimension of tertiary amine where there will be no visible reaction. Even in the case of primary amine with gas bubble, well, it's possible you see that, but I think out of these three dimensions, after that first test, where you suspect amine and amino acid, now to differentiate if it is an amine, I am feeling that you will be, driven towards confirming secondary amine, because that one is a bit unique. You can see the observation there, a color which is yellow color, and the liquid will be oily. You know what it looks like when you have your oil, let's say vegetable oil sprinkled in water, okay? And then you also perceive a fishy odor. Then you know it is secondary amine. So you have been able to confirm that, yeah, from the first test, 1AI, where you suspected amine and amino acid, yeah, what is actually there is secondary amines. Now, observe the reagent you used here. Sodium nitrite plus hydrochloric acid. Okay, now let us assume that it is not amine that is there. After you carried out the first test, 1AI, sample E plus ninhydrin solution, blue color or purple color forms, you suspect amine or amino acid that, okay, these are the guys present. Let us now assume that in the instruction, okay, say the examiner knows that it is not amine that is there. In the instruction, the examiner now drove you towards the direction that will confirm amino acid. Of course, you know in that case, this reagent here, reagent in 1AII, 1AIII, 1AIV, you won't see that again in the instruction. You won't. You won't. Of course, the examiner will now follow the instruction up after that first test. The examiner will follow the instruction up with the reagents that you will use to confirm amino acid instead. Okay? Now, before we move on to that case of amino acid, I want to tell you something here. This case that you say primary amines present or secondary amines present, you can also add, if you want, amino acid absent. You can add, if you want, in that inference. Okay, you can just amino acid absent, primary amines present. If you want, it's not compulsory. If you don't want, you can just leave it like this, the way you've seen it on screen. Let us move on. Assuming now that it is not amine that is there, that amine is actually absent, your examiner will not follow that 1AII with the fact that you should add sodium nitrite. Okay, I don't think your examiner will do that. And even if your examiner asks you to add sodium nitrite, for example, but your examiner knows that it is not amine that is there, if he asks you to add sodium nitrite, there will still be another instruction that would make use of the reagent that is used to confirm amino acid, so as to help you know that yes, it's actually amino acid that is there. In that case, let me just kind of define it clearly now. That first instruction, sample E plus ninhydrin solution, blah 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 blah, your observation and inference, you are done. Your examiner wants to confuse you more. The examiner wants you to differentiate, so really identify, is it amino acid or amine that is there? But then the examiner wants to confuse you. Let us assume that somehow, some way, the organic sample E is actually amino acid. But then now, listen, after that first test, 1AI, remember we are saying that assuming that it's amino acid that is there, but the examiner wants to confuse you more. Imagine now the examiner presents it. The second instruction. So the solution of E, add sodium nitrite and add hydrochloric acid. Remember what I said. Maybe your examiner knows that amine is not there, that it is amino acid. But then the second instruction is telling you to add this reagent that is used to confirm amine, which is sodium nitrite and hydrochloric acid. The examiner won't stop in that second instruction. The examiner will still go further to third instruction, where he will now give you the reagent to confirm amino acid. In that case, the second instruction, where you are using sodium nitrite and hydrochloric acid, if you add it, you see this observation you have here, let us assume, okay, that the case of secondary amines, which is 1AIII, number 3 of it, that yellow oily liquid with fishy odor, you won't observe anything like that. You won't. In fact, it would be like no reaction. It would be like what? No reaction. And if there is no reaction in that case, then you know that secondary amine is not there, or amine is not there at all. If there is any amine you might suspect, it will be tertiary amines. But in fact, in that case, amine will not even be there. You will now go to the third instruction, where your examiner will now expose you to this. Now look at what we have showing, the next slide showing on the screen. Observe 1BI. 1BI is still the same as 1AI. Look at sample E plus ninhydrin solution and heat. Look at this one, 1AI, sample E plus ninhydrin solution. Yes, whether you are heating the other case or not, you are adding ninhydrin. That's our interest. Now look at the observation, blue color or purple color forms. Look at the inference, amine or amino acid present. But remember that the next instruction helped us to confirm the presence of amines. Now look at this one now. 1bi follows 1ai exactly. Look at the observation, the same thing. Look at inference, the same thing. Amines or amino acid present. Like we now said, just look at the fact that it is not amine that is there, not amine. Your examiner will not go in this direction of 1AII, 1AII, or 1AIV. No. The examiner will rather go in this direction that will help you confirm amino acid. You can see that 1BII. 1BII. Did you observe what is happening there now? So if it's amino acid that is there, even if your examiner wants to confuse you so that you can report a negative inference. And what do I mean by negative inference? Where you would write, so thing is absent, so homolog is absent. Maybe like that question I asked you, that assumption we made, assuming it is actually amino acid as sample E is. But then you have added anhydrine, the first test, you've written everything you need to write. The second instruction, they now ask to add sodium nitrite and hydrochloric acid. But then the examiner knows there is amino acid that is there. In that case, the observation you will see will not follow a mean. It won't, which means you now say that a mean is what? Absent. Now the examiner will move on to the third instruction, where the examiner will now expose you to using a specific reagent that is used to confirm amino acid. Now you have them here, so let us move on quickly. 1BII. Solution E plus millions reagent. Solution E plus millions reagent. Now, if you add millions reagent to an organic sample and then in the test tube you observe a red precipitate. Now, I have decided to start using or reporting this thing in past tense now. I've started reporting in past tense, so follow the format now. I've been using simple present tense. I've decided to start reporting in simple past tense. Remember, I told you can use any of the formats, but don't mix them up. If you're reporting in simple present tense, follow simple present tense throughout your report. If you're reporting in simple past tense, use simple past tense throughout. I've decided to use both so that you learn them, anyone you want to use through, okay? If you add millions reagent to an organic sample and then you observe a red precipitate, so you can see the observation there. A red precipitate formed. I did not say forms again. Say formed, simple past tense. What will now be your inference? Phenolic amino acids present. Phenolic amino acids present. If you don't even want to overpunish yourself or overstress yourself, phenolic, that is amino acid of phenol. If you don't want to specify phenolic acid, don't worry. If you don't want to specify phenolic, you can just simply write amino acid present. Yes, you can simply write amino acid present. If your examiner does not expose you to millions reagents to confirm that it is amino acid that is there, not a mean, the examiner might choose to drive you in the direction of 1BIII. That is 1B3 there, okay? You can see that showing on the screen. Solution E plus Birette reagent. Solution E plus Birette reagent. Look at the observation there. In the test tube, you're going to observe a violet colored precipitate. So you see the observation. A violet colored precipitate formed. So do you see what happens? The use of Birette reagent. The use of Birette reagent. A student that is going for an exam or a practical work, and then you are being given this Birette reagent. One thing you should know is that that reagent is used to test for amino acid or proteins. You know, protein, amino acid, they are of the same form. Biologically, you are told the end product of protein. So in protein, the end product is amino acid. So amino acid, protein are the same thing. Those of you that are biologically inclined, you know what I'm talking about. Okay, you know what I'm talking about. So whether amino acid or proteins, still okay, no problem, any one of them. So Biuret reagent, observation, you will see violet color precipitates. Then now say amino acid. For one thing, like I said, for the examiner to even mention any of this reagent, it means really they want to confirm amino acid. Yes, 90% confidence that actually is amino acid they want you to confirm. Otherwise, why bring in this reagent at all? Except, like I keep emphasizing, that is why you have to try to carry out a test at least. Except, as I kept emphasizing, if the examiner want to test you in the negative direction, like in this case, now let me still bring in, assuming it is not amino acid that is there, that is actually a mean, like the one we just treated before this one now. That's actually a mean, but the examiner wants you to go in the negative direction before linking to the positive to confirm a mean. What the examiner will do after that ninhydrin test, number 1 BI you are seeing there, or number 1 AI as you've seen, the examiner will give you reagents for amino acid. For example, maybe millions reagent, or Biuret reagent, or maybe concentrated triosonitrate, 5 acid followed by heating, cooling, and then adding sodium hydroxide. Now, I always try to manage up the network situation so as to give you guys the best. It's not easy from here with respect to network sometimes. Okay, so this one BIV, sample E plus concentrated triosonitrate 5 acid and heat, then cool. After which you add sodium hydroxide. After which you add sodium hydroxide. This tests method, that reagent there is called Benedict reagent or Benedict solution. Okay, adding triosonitrate 5 acid and then heating, after which you add sodium hydroxide. So that guy is called Benedict what? Solution. Take note of that. It's called Benedict solution. Look at the observation there. So if you see a yellow color, that yellow color is expected to form when you cool that, solution. Then the yellow color will change to orange. The yellow color will do what? Change to orange color when you add sodium hydroxide. So when you observe that in your test tube, when you carry out this test following this method, it confirms amino acid as well too. Does that make sense? But if you don't see this observation, it means that amino acid is absent. But like I said, definitely your examiner must provide you with a reagent that will help you confirm what is there in the organic sample. But these are the things you need to be well prepared for. Get to know them, have them in your brain, know all this reagent, know the observation. That will help you to know what you're anticipating. Like I also kept saying, in case. Okay, Martin Sigwechi Diebere, you're welcome to the class. All right, we are moving on. Next, sample F. Sample F. Like I say, we are getting close. We are getting close to the end, okay? The last sample I consider is sample G. So you say after F, the next should be G. All right. So we are done with all these homologs so far. We've treated alkanols, we've treated the carbonyl compounds, we've treated alkanoic acid, we've treated amide, we've treated amines, we've treated amino acid. Let us now consider, assuming that you happen to be in the exam hall and in your own question paper, they are testing you on another different homolog. Let's see what we have here. You are given an organic sample. I decided to label it as sample F. I decided to label it as sample what? F. And then in the instruction, in the question paper, you are asked to add dilute hydrochloric acid or, take note now, either you are adding dilute hydrochloric acid to that sample F, or you are adding sodium hydroxide to that sample F. Assuming that on carrying out these tests, in the test tube, you now observe a colorless gas with choking smell evolved. You now observe also that the gas turned red litmus paper to blue. Remember, anytime a gas is coming out, of course, you will observe it because it will be coming out like either steam, vapor, or smoke. Are you getting me right? Something like that. Once you see that, it's expected that you use your what is it called? Yeah. See, my brain is gone. Use your litmus paper. Use your what? Litmus paper. Once a gas is evolved, use litmus paper to test to know whether the gas is acidic or alkaline. In this case, the gas turned red litmus to blue. Since the gas turned red litmus to blue, the inference would be alkaline gas. The only alkaline gas you have is ammonia. Okay, so you are going to record it this way: alkaline gas, ammonia from hydrolysis of CN, hydrolysis of nitriles. Because this method, this test method you have here, adding dilute hydrochloric acid to a given organic compound, or adding sodium hydroxide to that organic compound and heating, and then you observe a colorless gas with a choking smell or pungent smell, and then that gas turned red litmus to blue. This is characteristic reaction of nitriles with the reagent in that test method. So once I see this happening, I'll know automatically that the organic sample F contains the nitrile group. I can see the inference there, okay? Now let's move on. Assuming to that sample F, let us say a second portion of it. Let us assume a second portion of it. You are asked to add sodium nitroprusside. Sodium nitroprusside. If you are asked to add sodium nitroprusside, and then you observe that the solution turned red or purple. You observe that the solution turned what? Red or purple. Once this is the case, then the inference would be nitrile group present. So this is also the test for nitrile groups, okay? This is also the test for nitrile group. You can use sodium nitroprusside. Because sodium nitroprusside is actually used to test for nitrogen, which exists in the form of cyanide. Okay, this sodium nitroprusside is used to test for nitrogen, and that nitrogen exists in the organic compound in the form of cyanide. That is why this sodium nitroprusside is used. But observe the color changes. Either the color will turn to red or the solution will turn to what? Purple. I think sodium nitroprusside on its own should be colorless also. But by the time you add it on the organic sample, and that organic sample, if it is nitrile, that sodium nitroprusside color would turn to either red or purple. So that is that, and we are done with our main homologues. Remember, in your Chem 102, organic chemistry, all right, the normal class work, not laboratory work, there are 14 homologues you are treating. Out of it, we have covered in terms of the practical now, because your Chem 102 knowledge, we guide you also in this practical, but good enough, I've done the analysis for you, okay? We've treated the test, observation, and inference for alkane, alkene, alkyne. Someone might be asking, sir, when did you do this? Miss Summer Miracle, you're welcome to the class. Someone might be asking, so when did you do this? When did you teach test for alkane, alkene, alkyne? I did that during your weekly laboratory work. On this channel, slide through to Chem 107/Chem 108 playlist. The first 4 videos are based, video lectures, the first 4 video lectures on that playlist are based on your Chem 108 practical. Okay, so you have the lecture video that deals with test for saturation and unsaturation. That is where you treat both alkane, alkene, and alkyne. Then after that, we've treated, test analysis for solubility. That is solubility test. We've done that. It's there on this channel also. Okay. And then on this channel, the elemental analysis, isolation and identification of, elements that are present in organic compound is there, where you actually treated this concept of sodium nitroprusside, okay, forming the hexacyanophilate groups. The lecture video is available. Make use of it, please. I just decided to cover these ones we've not highlighted on this channel. Now, we are also done with tests, observation, and inference of alkanols. We are done with test, observation, and inference of alkanals, number 5. We are done with test, observation, and inference of alkanones, number 6. We are done with test, observation, and inference of carboxylic acid, alkanoic acid, number 7. All these ones, they are here on this particular live class. We are done with test, observation, and inference of amide group, acid amide. It is one derivative of alkanoic acid. We are done with test and observation of esters in a way, esters, because they form aromas, they have this aromatic odor, okay, sweet smelling odor. This is one way you identify them. We are done with test, observation, and inference of amines. We are done with test, observation, and inference of amino acid. And this one showing on the screen, test, observation, and inference of nitriles. These are the basic homologs that you expect. In your batch, you might see the question extracted from any one of these guys we've covered. Are you following? Starting from alkane up to this particular one on nitriles. But that is not all. Meanwhile, before we move on to the next one, I'd like you to see this is test for nitriles. This is how you identify it in the laboratory. So you go through, okay? This is for amines, for amino acid rather, for amino acid. We have covered that. This is for amines. This is for acid amide, acid amide. This is for alkanoic acid, also called carboxylic acid. This is for alkanals, also known as aldehyde. Of course, we worked that together with alkanones, known as ketones, okay? Look at it as well too. This is the beginning part. Then we had this as continuation. We are done with alkanols. Of course, that was the starting point of our live class today. Okay, that's the starting point of our live class in terms of this exam focused stuff. Does that make sense? I've told you that we have treated alkenes, and alkynes. On this channel, you have it. I've told you where to find it. Go to GMAT 41's playlist on this channel for alkenes, and alkynes, and then test for solubility tests. Alkane, alkyne covers test for saturation and unsaturation. Then separation techniques also is there under the playlist. All right. Now, starting from alkanol to the rest of the homologs, this live class, we've covered them. This is to prepare you for your examination, Chem 108 exam, kicking off from tomorrow for some schools. Okay? Now, we're going to conclude with this test now. Here we go. Test for starch and reducing sugar. Test for starch and reducing sugar. This, what I've just done here, the guys, right? The homologs that I am 95% confident, 95% confident, the exam questions will be coming from them. Remember, I've mentioned alkane, alkyne, then solubility tests, separation techniques, elemental analysis in terms of all these organic tests where you determine the element that is there, those ones are not covered in this live class. They are not. Check them under Chem 107/Chem 108 playlist on this channel. Exam questions can come from there as well too. Some of you will be tested on that area. So let us conclude. I know you've read through this, the last work as we call it, you know, a night. See, I have to rest. I've tried, it's not easy. I just returned from a trip. I had traveled since Thursday for something important. Of course, I had to answer the call, the invitation by our God and helper Jehovah, of course, to be taught by him. I attended a convention. The theme of the convention is pure worship, and I learned a lot, you know, that I would use to improve my life and also assist you friends. Coming back from the trip, of course, it's not in Oka. Coming back, I have to attend to you friends. So you see, it's not easy. It's not easy. I'm really doing the best I can for you friends. So remember to support GMAT 41. Yeah, support this channel, okay? Share the link to your friends, to your classmates, to your departmental WhatsApp group. I know from tomorrow till Friday or so, students will be taking exams on this course. So share this video lesson. Share it widely to as many as possible. Keep liking it, okay? Keep liking it. I hope the network is not tripping off now. Okay. Like the video, please. Very important. Very important. Like it and share it to your friends. Leave comments. Make comments here to appreciate the channel. Make comments so that YouTube can also recommend this lecture to as many as possible. Okay, I'll really appreciate it. Remember, you have to help others. You have to help others. It's very important. We are rounding off. I don't know. It seems like the network is breaking somehow. Let's see. Let me check on something. Is Chukwu Uchennu best teacher ever? Thank you very much. I appreciate the commendation. We thank our God and helper for continuously helping us. I am humbled and loyal to give you friends the best. Let us conclude, please. Now, look at these guys. Test for starch, test for sugar. You need to prepare for it as well, too. I don't know information I gathered. For those in Unizik, for example, I was hearing that some of you didn't do it also. But based on previous experience from last set, prepare for this guy. Whether you did it in the lab or not, prepare for this guy. Last set, that was what they did. Those in 200 level now. And they tested them on this aspect. Yeah, you know, this particular aspect is not part of your Chem 102. It's not part of the class work, the class teaching, the full theoretical part of organic chemistry, starch and sugar. So some of you might feel that, okay, they might not ask question on this in your practical work. They can. They did it last set. And that is why I also included it here. So let us conclude. Imagine that you are given a sample in this exam you are preparing for, and you are told in the instruction to sample so and so. I use G for it. Add iodine solution to it. If you add iodine solution and then in the test tube you observe a blue-black color, that is, say that blue-black color was observed. All right? Your inference should be starch present. Starch present. Okay? If you don't see blue-black color, it means that starch is absent. But of course, for them to give you this, there is high chances that starch is what present there. So we'll move on to the next one. Move on to the next one. Assuming that sample G, let's say that it is not starch that is there. Now they ask you to add Benedict solution to it. You're asked to add Benedict solution to it. And then in the solution, or in the test tube rather, you observe that there is a color change from blue to green, or to yellow, or to brick red. Take note of that. You see that the color you might likely see may not be the same as the color another person may see. It all depends on the reducing sugar in that case, right? So some persons might observe that on adding Benedict solution to an organic compound, the blue color of that Benedict solution changed to green, or changed to yellow, or changed to brick red inside that test tube. That shows that the organic sample is a reducing sugar. So the inference will now be reducing sugar present. Then, in conclusion, assuming to that sample you are asked to add Ferlin's solution, and then you now observe a brick red precipitate formed. If you observe this, then it is reducing sugar present. But look at this guy that I say reducing sugar present. You can also write, if you wish, yes, you can, and there is nothing wrong. You can also decide to say or aldehyde, because aldehyde also shows this observation with Ferlin solution. And that is true. That is possible. That makes sense, because aldehyde, alkanal, the functional group is CHO. I know that CHO is one major component of reducing sugar. So in this last case, if you like, you can still write that reducing sugar present. You can say reducing sugar, or you can also write alkanal, also known as aldehyde, present. That is allowed, because these two guys, they do the same thing. They show the same observation with Ferlin's solution. All right, guys, think it's been a wonderful one with you. I didn't talk about fat and oil. If you are tested on fat and oil, no problem. Basically, for fat and oil, you will usually be tested in the direction of translucent test. Translucent, where you might drop fat or oil. If it is fat, you rub it on a piece of paper, maybe a plain paper, then leave it for some times. If you rub it on a plain paper, let me see, you rub on a plain paper, you can decide to, after rubbing on a plain paper, if it is fat, then hold it against a light source. If you hold it against a light source, it will become, that paper will become transparent. That paper will become what? Transparent. That is called translucent test. That is called what? Translucent test. So I think for fat and oil, that's the direction I feel. If they are testing you on fat and oil, they will just link you to that translucent test. There was this guy I called the Benedict solution earlier. I think I have to correct something on it. Let me see. The addition of concentrated HNO3. Yeah. Look at this test for amino acid conformation. 1BIV. Sample E plus concentrated trioxonitrate 5 acid, then heat and cool, and then add sodium hydroxide. Please, that test is called xanthoprotic test. Xanthoprotic test. It is test for protein, test for amino acid. But I earlier mistakenly said, I think I called that Benedict solution or whatever. Please, I'm sorry about that. It's not Benedict solution. It was the name of the test I was trying to mention. Did you notice something that's happened? Something has happened. NEPA has struck. NEPA has struck. All right, but it's a good thing, as if they waited for us to almost be done before they struck. All right, so all the same, I think we have done some wonderful stuff today. I wish you friends all the best. Remember, your exam is not difficult. Remember, your exam is not difficult. I'm assuring you this. I'm assuring you this. You want to be confident as you're going into the examination hall. Listen to me, dear friends. Your examiners, they have nowhere to dribble you to. This is science we are talking. This is science. If A is confirmed using, let's say, W, your examiner cannot change it to say, okay, oh yeah, A is confirmed using K. It's not done. This is science, and these things have been established for us. So what you have to do is making sure you see all these test column, those reagents that were added, all those reagents that were added, then the observation we expect, which will help us to make the inferences that I made here. Memorize those reagents, please. That is the first thing you are expected to do when you are going for organic, when you are going for, I think this thing we call it salt analysis test, qualitative analysis, whether it is inorganic or organic. For inorganic, you did that last semester, and this semester, organic. Am I communicating? So the reagents, they are key. So make sure you memorize them. Then you now look at the observation. Okay, if I apply this reagent to so thing, and I see this observation, that this is what I am seeing in the test tube, my conclusion will be this. I will tell them that this is what is there. If this particular reagent, you know that this is what this reagent is supposed to do, but you are no longer seeing that thing. You are no longer observing that thing when you added that reagent. Two things are possible there. It is either your examiner wants to test you in the negative direction, whereby in that case where you are not observing that thing you are expecting with that reagent, you will now say that homolog is absent because you didn't observe what you were expecting, what you know that reagent is supposed to do. So that is one possibility. And in that case of that negative test direction, if your examiner drives you in that negative test where you would say that a particular homolog is absent in the first place, if the examiner goes in that direction, are you getting me right? The examiner must also go further in the instruction to tell you the reagent you are to use to confirm what is meant to be confirmed. There is no way an examiner will drive you in a negative direction without indicating further instruction to help you determine what is actually there. What I'm trying to say in essence is, if in between instruction, thank God, if in between instruction, your examiner gives you a reagent that you add, and then what you are expecting to observe, you are not seeing it. If examiner actually want to test in the negative direction, which in that case, you would mention that what you are expecting, that homolog is absent, the examiner must go further in the instruction to tell you to do something again. What they are going to tell you to do, the next reagent they will tell you to add, will now help you to confirm the main thing that is meant to be there. And so if you know all these reagents and what they are used for, whenever you follow that pattern, you can catch your examiner red-handed. I've told you this, like if I sit for all these tests, whatever, salt analysis, qualitative analysis exam, most times I might not even run the experiment. But please, just try to run. I'm not telling you not to go run. Try to run and observe some things here. It is only when the thing becomes extremely complex, because sometimes you might be running, you are not seeing anything, you can now constructively apply this secret I am revealing to you to write the observations and inferences. So if you are tested in a negative direction, examiner must follow it up with further instruction and a reagent that will help you confirm what is there. So that is one thing. The second possibility is that the instruction is completely off, is wrong based on the reagent they gave you. That is another possibility. In this case, you have no choice. It becomes a serious problem. It becomes a serious problem because, and I believe some of you experienced that in your laboratory work, your weekly laboratory work, because there were certain complaints, and reports. But like I said, now we find ourselves somewhere in a country where anybody just does anything that he or she wants. It's so sad, but God will help you people. In such case, still, you don't have any choice. You would fall back to your theoretical knowledge as I've given you this evening. Are you getting me right? In order to be able to answer the questions. But I pray and I hope, I have you in my prayers, that you won't have such terrible experience. Yeah, you know what I'm talking about for those of you that may have been having certain challenges in your laboratory. But I hope, like I said, this examination, they would have done their best to eliminate anything that would cause you trouble. I love you, friends. I wish you the very best in your exam. Go in there, hit the exam, all right? And get us those A splashes. Good night. And I'll see you later in the day. This is 12 o'clock a.m. from here now, okay? I wish you all the best. Success in your examinations. Please help me and share this video to others. Like I say, let's help as many as possible. Bye-bye.